So the vulnerability that seemed the most interesting over the past few days is called MacStealer. And no, it's not stealing Apple devices. It has to do with wireless networks and the potential to see information that belongs to another device. It applies a little bit differently if you're using a common password for authentication versus having to sign into a network. So in this video, we'll talk about the details of how MacStealer works. We'll talk about what the implications are in terms of potential impacts. And then finally, we'll talk about what, if any, actions you should be taking as an MSP. Is there anything you need to tell clients proactively and what you should do about it? So let's get started. Okay, so let's start with the enterprise example. That's the most common one and one that the research focuses on. We will talk about the other one in just a second. So I have my internet cloud here, goes to a LAN. That rectangle thing is supposed to be a switch. I don't know what it actually looks like. Because this is enterprise, there is some type of radius device here. Often that'll be backed by Active Directory, so it might be Microsoft and the NPS role sitting on a Windows server, but it could be anything radius. I know there are lots of radius appliances and things like third-party SaaS-based radius instead. Doesn't matter. All that matters is it's something here providing authentication. And then you have our access point, right, with the requisite little wavy Wi-Fi lines. Missed my calling as an artist, obviously. And we have two clients. We'll call them client 1 and client 2. And just to make things very simple and straightforward, we will say that client 1 has the MAC address of 1 and client 2 has a MAC address of 2. If for some reason you don't know what a MAC address is, it's a unique hardware identifier for a network card, right? So it's identifying a specific wireless interface, not necessarily the device itself. The interface just happens to be connected to the device. Client 1 connects to the access point, who makes him authenticate through radius, and the authentication was successful. Check. And the access point in client 1, set up a key pair so that this traffic is encrypted. Otherwise, we wouldn't have to do anything, and client 2 would be able to just use something like an air PCAP or some other type of promiscuous wireless adapter to just pull wireless packets right out of the air. So client 1 sends a request to a website. Maybe it's connectwise.com. The website sends the response back, and the access point says, okay, this is destined for MAC address 1. So he sends it over. Let's say that client 2 wants to intercept that. How does he do it? And specifically, it's the response that's being intercepted. It's not the entire session. And we'll talk about why in a minute. Well, after the request is sent to the website, client 2 sends a deauth packet to client 1, causing him to lose connectivity. He's gone. Client 2 then connects to the access point, but has switched his MAC address to MAC address 1. So let's just stop and make sure we understand what's happened here. Client 2 has connected normally. He's not broken into anything. He hasn't guessed a password. He hasn't stolen anyone's credentials. He connects with whatever his normal mechanism is. So if that's somebody's name and password, he connects with that. All he's done is connect with a spoofed MAC address, client one. So he's saying, hey, everybody, hey, access point, my MAC address, my identifier for the wireless card is 1. Here's my credentials to verify. Please set up a session key. When the response comes back, the access point is finishing its request that it had for client 1. And it says, okay, I need to send this to the wireless card at MAC address 1, which is here on device client 2. And because this is a successful session, it's able to be read. There's not an encryption. There's nothing he has to break. There's no decryption needed. I guess it's decrypted, but it's decrypted because it has a valid key. And everything is good to go. So the big threat here is that client 2, let me just erase some of this. It looks like, pasta all over the page here. Client 2 is able to see the response that was destined for client 1. That's the threat. That's the sensitive information that might be exposed. So if client 1 requested something sensitive, such as how much data is in my bank account, or what's the image for the CAPTCHA, or what's the link for the password reset, or anything like that, that might be exposed. Okay, so next we'll look at a more typical setup. This might be your home router. This might be a small business. It starts out the same. You have your internet here, and you have your LAN. Definitely the same switch model. And your access point. What you don't have is the enterprise authentication component to this. So you have your client 1 down here, again with MAC address 1, and client 2 down here, MAC address 2, and of course their Wi-Fi connections. So what happens here is that many of these access points, including home ones, have a feature called client isolation, which means that these devices can't talk to each other. This is also the case where you might have at a home network, like a private and a guest network, that guests or things like IoT devices or things like that go on. This is especially true if you don't have VLAN set up at your house, and we'll talk about that in just a second. When you have this kind of setup, the exact same thing can happen. Client 1 makes the request. Here we go. Client 2, deauth, poof, gone. Spoof MAC address. And the response that's supposed to be from client 1, router says, hey, let me send it to where I know client 1 is at his MAC address. And because we've done the association. Now, what's different about this is that client 2 didn't have to rejoin with valid credentials. He just had to rejoin with a new MAC address in this case. So we didn't have to explain like we're talking about a persona here, but he didn't have to set up a new session with that authentication, right? There is no Radius server or anything else here. That's the difference. When you see those kind of private and guest networks and you didn't have to configure VLANs, that's what's happening. And so again, the risk is that client 2 can receive a response destined for client 1. Okay, so let's talk about the practical impacts of this. First, remember that this is only for return traffic. You're not capturing an entire session. Second, and likely the biggest thing, this doesn't account for higher level protocols. And what I mean by that is if what's being transmitted over the wireless network is HTTPS or anything else that uses encryption, like TLS connections, like VPNs, like almost all protocols today, what's going to be intercepted is encrypted traffic and possibly what site you're visiting, although most sites are going to resolve to Akami or AWS or Azure or something like that. Anyway, the threat model isn't really any different than if you were on a LAN and able to see other traffic through ARP poisoning or any other type of shared medium attack. Third, when you're on a network that uses shared keys, a password, use separate VLANs for each SSID. Even if this attack didn't impact that, there is no reason to share SSIDs on a VLAN. And I always recommend using a separate VLAN for wireless and not just sharing it and piggybacking off the LAN. I've seen a lot of networks that do that, and I just don't prefer that from a design perspective. Fourth, if you're using a shared key network, the most likely attack is a rogue access point, an evil twin. Then you capture the entire session, not just the return traffic. So be more vigilant of that than this. And then finally, what to tell clients. Is there any action to take? This isn't one that necessitates some kind of proactive notification. If somebody asks you about it, then yes, talk to them about the risks and what it is. But tell them that in general, you treat their machines like they're on dangerous networks anyway, all the time, at the coffee shop, at the airport. This is no different. And the sensationalist name in MacStealer doesn't mean that they need to start worrying. From a purely technical engineering perspective, this is a really interesting and cool attack. From a risk management perspective, this is not one that you need to spend a lot of time on. For more content like this, follow me, Matt Topper, on LinkedIn, and come visit us at IT Nation Secure this June. We'll be talking about security both from the technical perspective and from the overall risk management non-technical perspective. Hope to see you there. Thanks.